Did you know the food on your plate is the result of cutting-edge science? Welcome to This Explainer. Today, we're tracing the incredible, sometimes crazy path of the food we eat. We're starting right at your local grocery store shelves. Then we're going to head out to these massive industrial operations on the open ocean. And finally, we're taking this whole shebang all the way up into the zero-gravity environment of deep space. You know, as consumers, it is just so easy to take the modern supply chain for granted. We pick up this perfectly packaged box of cereal or a pristine fillet of fish, but we rarely stop to think about the literal technological hurdles that had to be overcome to get it there. So, shattering that disconnect, realizing it doesn't just magically appear, is our first step into the rigorous, deeply fascinating world of food science. Okay, let's dive into this with the official textbook's definition. Food science is the application of the basic sciences and engineering to study the fundamental physical, chemical, and biochemical nature of foods. So what does that actually mean in plain English? Well, it means that virtually all the foods we consume are derived from living cells. They are essentially edible biochemicals, and scientists and engineers are out there actively manipulating these biochemicals to make absolutely sure our food is safe, nutritious, stable, and, of course, delicious. They're using hardcore chemistry, physics, and mechanical engineering to transform raw crops into the very items you recognize in your pantry. Section 1. Creating new food products. When we actually look at the lab environment, the sheer scale of product development is just staggering. Get this, in the United States in 1993 alone, there were over 12,000 new food products introduced to the market. 12,000! We as consumers are constantly demanding healthier, newer, and more convenient options, right? And the food industry relies on scientists blending rigorous chemistry with culinary creativity to meet that relentless demand. And this brilliantly illustrates what that looks like. When a food scientist works at the bench to optimize a formulation, it impacts almost everything we end up consuming. Take diet soft drinks, for example. Scientists figured out that replacing standard sugar with aspartame drastically reduces the caloric content. Why? Because aspartame is actually 200 times sweeter than sugar. 200 times! So you only need a tiny, tiny fraction of it to achieve the exact same taste. That's applied chemistry directly impacting your daily diet. Another really fascinating challenge is manipulating fat content. So fat contains 9 calories per gram, while protein contains only 4. If a food scientist wants to create, say, a low-fat ice cream, they can't just take the milk fat out, or it totally loses that creamy texture we all love. Instead, they actually process those 4-calorie proteins into microscopic particles that physically mimic the mouthfeel of fat. It's like a magic trick. The result? You get the smooth texture of traditional ice cream, but with a significantly lower caloric footprint. Let's move to and see how this builds into Section 2, floating factories at sea. Scaling way up from the lab bench, we find some of the most massive industrial marvels on the planet operating right out on the open ocean. Now, to understand why these giant factory ships exist, you have to understand fish tissue. It is highly perishable. As fleets had to travel farther and farther to find fish, a catch could easily spoil in the hold before they even reached port. The engineering solution? Literally put the processing plant directly on the boat. Now, what's really interesting about this slide is the extreme level of automation floating out there on the sea. These ships are equipped with automatic separators for different sizes of fish, mechanized eviscerators to clean them, oil extractors, and fully automated filleting machines. They even house quick freezing facilities and fish meal plants to convert the less edible portions into byproducts. This incredibly rigorous factory approach minimizes the loss of valuable protein and fat, allowing these vessels to just stay out at sea for 2 entire months or more. It's wild. And when they're finally unloading the final product from the cold hold of a vessel, the results of all that engineering are super clear. That fresh, high-quality piece of seafood you eventually buy at the supermarket, it's a direct result of these rigorous industrial methods. The food science applied right there at sea guarantees those highly perishable biochemicals remain safe, intact, and nutritious for you to eat. Okay, moving on to Section 3, feeding astronauts in space. Now we're looking at the absolute most unforgiving environment where food scientists operate. I mean, the stakes up here are incredibly high. Scientists working with NASA face extreme weight limitations, virtually no refrigeration, and highly specific dietary needs caused by the physical stress of spaceflight. Furthermore, and this is a big one, in zero gravity, A loose crumb or a stray drop of liquid isn't just a mess to clean up, it is a critical danger. It could float right into sensitive electronics or even be inhaled by an astronaut. Every single meal has to be literally engineered around that severe hazard. So, the crucial point is, because of these immense challenges, this specific branch of food science is evolving super rapidly. In the early days of the space program, astronauts simply added a small quantity of water to dehydrated foods in a pouch and squeezed it through a tube into their mouths. Pretty basic, right? But looking toward future voyages into deeper space, where resupply missions are entirely impossible, scientists are having to develop completely closed-loop systems. Right now, they are actively researching complex recycling methods and figuring out how to actually grow and process foods in the zero-gravity vacuum of space. From manipulating the microscopic proteins in your low-fat ice cream, to engineering floating factories on the high seas, to literally growing crops on a spaceship, food science touches every single aspect of our lives. It really is a discipline of endless innovation. So, knowing the incredible leaps we've made just in the last few decades, how do you think food science will shape your diet 50 years from now? Thank you so much for joining me on this explainer, and keep your curiosity hungry.